Parameter estimation using Excel solver. We can find the unknown parameter value. The objective is to estimate the parameter of K1 and K2 by using parameter fitting to minimize the total sum square error. And the tools used is solver in Excel. According to ChooseHeva, Excel solver add-in is very useful to solve mathematical problem, and sometimes it called as a linear programming solver to make the best decision. Advantages of Excel solver. So it is easy to use, fast and intuitive, give the optimal solution with the best parameter fitting, and give us to set up the constraint if need to have the specific condition. And it also has objective cell that user can change according to their choices, such as maximize, minimize, and also a specific value. And it has up to 200 adjustable cells that can be specified. Disadvantages of Excel solver. Richard 2021 stated that limitation of Excel solver is especially when fitting projection model. It cannot work more than 200 parameters, which need to optimize to fit the model. So how to add in the Excel solver in Microsoft Excel? So firstly, to use the Excel solver, user need to log in the Excel. Go to File and choose Option, and go to Add-ins here. And under Add-ins option, click Solver Add-in. And then you click Go. Mini tab will pop out. Make sure you tick the solver add-in and click OK. To use solver add-in, go to Data tab and under the Analyze group on the right hand side. So solver is here. And after clicking the solver button, it will display the solver parameters tab like this. Inside objective, or sometimes we call it as target cell, is the cell that we target to change. And then we have here is 2. So user can choose either one to maximum, minimum, and you can set the value. If you want to set the value, you click here and put the value here. And also user can select cell that want to be changed in order to achieve the target cell by changing variable cell here. For the user that want to put the constraint, so you can put it here and it will pop up like this. So just enter the cell reference and then the symbols and then constraint. Next is to make sure the answer is non-negative. User can tick the make unconstrained variable non-negative, this one. And after the input of the all parameters have been defined, and then you can click solve, and Excel will show the answer for user at Excel spreadsheet result. Model validation. So there are 3 types of model for the population with death but no birth and immigration. So we have here model 1, discrete formulation. PT is equal to K power of T times P naught. Model 2, ODE with 1 parameter. We have here dP over dt is equal to K times P. And lastly, model 3, ODE with 2 parameters. dP over dt is equal to K1 times P times 1 plus P over K2. Model validation, parameter estimation for model 1. Before parameter fitting is the line curve with the orange color when K equal to 0.6687 and the total sum square error is 261.0277. And after parameter estimation, our K is 0.5293 and the total sum square error has decreased to 22.1141. So after the parameter estimation, for this model, model 1 is the best curve compared to before the parameter estimation. This is parameter estimation for model 2 exact method. Before the parameter fitting, the orange curve, value of parameter K is equal to negative 0.4024 and the total sum square error is 261.0839. And after the parameter fitting, with the line curve is the green one, our value of K is equal to negative 0.6363 and the total sum square error has decreased to 22.1141. In this model also, after parameter estimation is the best fit for the data experiment. And this is for the numerical method, model 2. Before parameter fitting, the value of k is equal to negative 0.4024 and the total sum square error is 261.4345, this orange curve. And after the parameter fitting, green curve, the value of k is equal to negative 0.6378 and the total sum square error has decreased to 22.1141. After parameter fitting is the best curve to the data experiment rather than before parameter fitting. And lastly, parameter estimation for model 3. So before the parameter estimation, the orange curve, our K1 is 0.3313, K2 is equal to 20, and the total sum square error is 100,898.368. And after parameter fitting, you can see the green curve, our K1 equal to negative 0.0797, K2 is equal to 1.6326, and the total sum square error, it has decreased to 3.0294. And this is the comparison between the all model. We have here data, the blue dot, model 1, model 2 exact method, model 2 numerical method, and also model 3. Data is the blue dot, and then we have here model 1, the orange color, and the pink color is model 2 exact method, model 2 numerical method is purple color, and model 3 is red color. Model that has the best fit for the data experiment, you can see here, model 3, the red line curve. And if you look at the total sum square error, model 3 ordinary differential equation with two parameters has the least total sum square error rather than model 1, model 2 that are using exact method, and also range cutoff order 4. So from the result, model 3 has the least sum square error, that is 3.0294 rather than model 1 and model 2, that is 22.1141. So it shows that using two parameter estimation are more accurate rather than using only one parameter estimation. Based on the graph, model 3 is much closer with the population data rather than model 1 and model 2. Conclusion. In this research, we conducted an experiment using m&ms simulation for population with death but no birth and immigration. We built a mathematical model using discrete formulation and ordinary differential equation referring to the data from experiment. Parameter fitting has been used in order to find the least total sum square error. A parameter fitting is proposed and mathematical model using two parameter ordinary differential equation, that is model 3, is the most suitable to represent the data with the least sum square error. The parameter fitting is performed by using Excel solver, which gives the minimum sum square error by finding the best parameter. Extension is the example of real-life application for this project. Thank you.